Okay guys, welcome to your second flip with Mr. Morrissey. I'm going to do another video, this time on physical and chemical changes. So it's the same deal. Again, this is posted on Verso and you'll have a chance to take some notes. So the first thing, before we get started, you'll notice if you go to Edsby today that in Edsby there is a pinned item called Cornell Notes. So now anytime you need those notes, that note-taking system for these types of activities, just grab the Cornell notes and put them in your OneNote and title them properly. Okay, so today we're going to start with chemical and physical changes and the difference between the two. So the essential question for today is, how do we differentiate between a physical and chemical change? Okay, so that's your key question. That's what we're going to try and sort of accomplish today. Now, I've been informed by multiple people that I was not very interesting the last time through, so I'm going to try and make this a little bit more interesting and try and shorten it up a little bit so you guys will enjoy it a little bit more. Okay? So the key thing, the first thing we need to determine though, is what is the difference between a chemical and a physical change. Okay? So a physical change is basically just a change in sort of the state or a mixing of compounds, as you'll see right here. Okay? There are new properties may appear, but the key thing here is no new substances are formed. Okay? So what that means is all substances are still the same. Still the same substance. Okay? On the other hand now, a chemical change is you have to have at least one new substance formed. And what that means is a chemical reaction had to take place. So that means bonds have been broken and new bonds formed. Okay, so now you have at least one new substance, you've got at least so there's going to be some different properties, and it's very difficult or impossible to reverse this. Okay, so for example, physical change, you're boiling water. Water is still there, and it will condense back to be liquid again. Whereas in a chemical change, often it's much more difficult to change that back. When you burn wood, for example, you can't convert it back to wood. Okay, so chemical change, it does not necessarily have to be two substances combining to create one new substance. It can be reversed, but it has to be sort of a big change. So the first example of something that you might indicate a chemical change is a color change. So if there's a change in color or a precipitate, so a solid forming from two liquids, these are indicators that a chemical change has occurred. And so to help view that, here's a quick video of a chemical change. So you'll see this is lead nitrate, these are two clear liquids being added together. So potassium iodide is being added to lead nitrate, and now you're seeing sort of that color being formed, and you can see some solid produced in there. So let's just back that up a little bit. Okay, so two clear liquids being added together, and again you're seeing color formed and a solid forming in those liquids. Okay? The second example, okay, is you will have a temperature change. So flame appears or it gets cold. So it can also, removal of heat gets cold. An example of that would be an ice pack. That's a chemical change. Okay, there are two chemicals in sort of glass vials in an ice pack, and you break the glass, the two chemicals come together and create this ice pack, which sort of eats up all the heat from their surroundings. Okay, it can also be, there's heat or fire produced, and in those cases, there's heat. So this is another example here. There's a temperature change and a gas produced. So a gas produced is the other one. Can be odorous, but does not necessarily have to be. So bubbles formed is the other option here. So you get an odor or bubbles being released. So let's take a look at that example. Okay, so you can see we've got a temperature of about 20 degrees here. You've got your sort of your liquid in the bottom, the temperature, and so then we're going to add some baking soda. See what happens. So your baking soda has been added to the citric acid solution, and now you can see bubbles forming. All right, so bubbles are a sign that there's a gas being produced. Now you've seen bubbles being formed when you boil water, and that's not a chemical reaction because you're heating it. In this case, if you don't add heat, and heat is produced, or bubbles are produced, then you can assume there's a chemical reaction taking place. So I can drag this forward a little bit, and zoom in, and you can see in this case actually heat has been removed, so the temperature has actually gone down in this situation. Okay, so this is another example. There's a temperature change, not necessarily an increase in temperature. Okay, and the last but not least, often you can have sort of like a pop or a noise is heard, similar to an explosion, and along with that, you get sort of gases being produced. So a pop here, pop being an example, not pop as you would, not sort of pop as in the, but like a popping sound. So we've seen flame appear, or we've seen heat, or heat becoming away. We've seen that odor released. The noise, we're going to hear that this time. You've seen a color change. You've seen the precipitate form. Now we're going to see the flame and noise all in one. Okay, so this is an explosion. And now you've got sodium, which is a very soft metal, as you can see. Okay, we're going to cut that. Just like this. And you can take the sodium, and if you drop it in water, very simply, just regular water, you will get a similar reaction that looks something like this. And so there's a popping sound and sort of crackling and that flame being produced. So that's that example of that chemical reaction. You could also try a bigger piece, and let's see the reaction we get here. And often you'll see this effect in fireworks. Different metals will burn different colors, and so that's where you get a lot of the colors in fireworks from, is that reaction of different metals being burned. Okay? Now this is just a note. Just because color changes doesn't mean a chemical reaction has taken place. If it's an additive color change, it does not necessarily mean you will get a chemical change. Okay, so if it's additive, in sort of, for example, red plus blue giving you purple, you may just have two colors mixing together. And that would be an example of a physical change. And so that leads us into physical changes. And basically the difference here is you get no new substances created. Okay, so water is still water when it boils. You can change the state. So, for example, water to liquid. Liquid to solid, or solid to gas, all those types of things, right? So that transition from one thing to another. Okay, or you have a mixture created. So as in the last lab that you saw, we dissolved oleic acid in water, and so a mixture was created, a solution, but not necessarily a chemical reaction. Okay, so you don't see that sort of that non-additive color change or any of these signs of a chemical change. Okay, so if you don't see these signs up top, generally it means there's a physical change. Okay, so you're going to have to use all your observation skills. We're going to do some examples in class this time, and then before we go away for the break, and then after we get back from the break, you can get a chance to actually observe some of these yourselves. Okay, hopefully you enjoyed. I'm trying to get better every time. Thanks, guys.